My name's Matt, and I've just finished my Masters at Plymouth University, and my dissertation was on diatoms and what the biology can tell us in the Tor catchment and its subcatchments. So my talk will consist of what is a diatom and their uses, what's the problem in the Tor, and followed by my aims and objectives, my methodology, my results, and my conclusions. So what is a diatom? Well, a diatom is an algal-type organism belonging to the kingdom Violata. It is neither plant nor animal. It is a microscopic organism and is unique among algae in that it has a silicon cell wall which has several benefits, such as it is energy efficient and it has an advantage when photosynthesis is limited. There are 10,000 to 12,000 currently known species of diatoms, and there are 285 genera. So diatoms form the basis of many food chains because they are a primary producer, particularly in the aquatic environment. They're able to occupy a range of environments, so you have marine and freshwater to soil and alpine, and even as far as bird feathers because they're so abundant. Diatoms also bloom earlier than other algal species, and this blooming has also resulted in diatoms getting smaller through each progressive reproduction stage, which has led to a variety of forms when identifying them. So Gomphonemia parvulum has 27 currently known species under identification. So the uses of diatoms. Due to the unique nature of the diatom cell wall, when it breaks down it forms a silicous material, which then makes biogenous sediments and diatomaceous ooze, which eventually hardens to form diatomaceous earth. Now this is used in a number of products we use every day, such as swimming pool filters, temperature and sound insulators, beer clarification, which is very important. And diatoms are also used in rigor mortis to determine if a victim had died of drowning, if they're present in the marrow. However, the most common use of diatoms under the European Union Water Framework Directive is as a bioindicator to determine if the ecosystem is healthy or not. So what's the problem? Well, the problem is that fish sightings in the Tor catchment, subcatchments, have been low compared to previous years, which has been due to a decline in river health. This decline can be from all sorts of factors, such as cows entering the rivers and defecating, surface runoff from roads and fields, etc. And then this has a knock-on effect along the food chain. So as a primary producer, diatoms will be the first to feel this change, and this will then have an effect on the higher species such as fish and possibly otters. So what makes diatoms a good bioindicator? Well, diatoms have a rapid growth stage, which means that they are very good when it comes to change. They're sensitive to chemical change because of the pores within their silicon cell wall, yet because of the silicon cell wall, they're resistant to the physical processes of the river. The cell wall also resists decay, enabling a diatom fossil record. Diatom is also one of the most abundant algal species found in lentic and lotic systems, and is this abundance has created different tolerances. So for example, in colder waters, you'd expect to find more navicular lanceolata, and Coconus placentula, they're more of a pioneer species, so able to take a foothold on most substrates resisting grazing. Okay, so the aim and objectives of this project was to analyse diatom populations found within the Tor and its subcatchments, Lapford Yeo and Little Dart. This was then to analyse the compositions and then produce EQRs, which could then assign the ecological statuses to each catchment or sampling point. The second objective was to make a seasonal comparison, so not only collecting data in winter, but also in summer, to see then how the populations differed. And then this data can then be used in conjunction with phosphorus levels to then see, has it got better, yes or no. So the methodology. At the start I referred to the method set by Kelly et al. 2001 for this project. So when going out into the field, 5 stones were selected. These stones were then scrubbed with a toothbrush, very technical, and these scrubs were then transferred to a phial. Alcohol was then added to the phial for preservation. The samples were then taken back to the lab and purified using hydrogen peroxide. The samples were then put onto cover slips and then left to evaporate over a 12 to 24 hour period, leaving behind only the diatom cells. And then these were mounted onto microscope slides using Nafrax. Now Nafrax is a mounting agent which looks very similar and has the stickiness of golden syrup. And under a microscope, 300 diatom cells were counted, moving left to right, starting from the top left, counting only the whole diatom cells. So any cells that were broken were not included in the count. There were 3 sampling points per location, so I had 15 sites per catchment, so overall I had 45 data sets for winter, 45 for summer. And then once all the diatoms would be counted, the TDIs were then worked out, which then using some statistics and algorithms, I was able to produce the EQRs. Now onto the results. Once the EQRs had been calculated, it was possible to assign the ecological status to each site using the maps and the EQRs. So as you can see from the graph, there's a notable difference between Sheepfold, 1TW015, and the other locations found in the main Tor catchment. On the right is a graph showing the phosphorus levels. As you can see, it's really sort of small in the main Tor, but at week there is a large phosphorus level, which, if you can see on the graph, it is the smallest just by only a little bit, and that it has the lowest EQR score compared to the others in the Tor. Whereas Sheepfold is so minute in the phosphorus levels that the ecological status is good, and that is according to the boundary tables on the bottom right. And also, because there's such a difference in ecological scores, the composition of the diatoms found in the areas were much different. So in Sheepfold, we found a lot more oligotrophic species, so Eunotias, Actinanthes, Peronia, Fibulae, and then when you got down to these locations, the composition had completely changed to phosphorus tolerant species. So you had a lot more Sorelia, Navicula, Nitschkias. This is the results for Lapford Yeo. As you can see, it's not as good as the Tor. Particularly mention 1DY012. The diatoms we found there were a lot more sensitive, they had higher scores, so this brought down the ecological status. So all the moderates, they're much smaller than the ones in the Tor, and mention is graded poor, even though it is just 0.01 away from being moderate. And also, according to the map, the phosphorus levels were much higher in Lapford Yeo compared to the Tor catchment itself. So unlike the Tor and Lapford Yeo, the phosphorus levels in the Little Dart, they're a lot better than either of the two, and overall, averagely, the EQRs bordered moderate and were close to being good. A lot more of them reached 0.6 plus, whereas back to the Tor and to Lapford Yeo, none of them reached 0.6. So this is the seasonal data that I obtained for the Tor and its subcatchment Lapford Yeo. Now I'd like to apologise in advance, but due to time constraints, I wasn't able to produce data for the Little Dart, and only the repeat C was used because of some slides A and B. There's a lot of diatoms missing from those slides, so I couldn't get count of 300. So in the tour, during both winter and summer, the pattern was very similar. There is a slight peak there, but in the grand scheme of things, according to the table, this is still moderate. It's still declining from a good ecological status to a poor one, or moderate, which is moving from the moors where there's less activity, cleaner water up there. And then in Lapford Yeo, the same story. There's a gradual increase in winter, but a gradual decrease in summer, which may be related to flows. But as in the grand scheme of things, it is still moderate, and as you move downstream, it is progressively getting worse and worse. So to conclude then, Sheepfold was the closest site to the reference conditions because it had a good ecological status. It had a value of 0.91 and the pass mark was 0.93, so it's very, very close. And it was the only site to achieve good ecological status. Whereas all the other locations in the tour, they failed to achieve that good ecological status, which is very similar to a study by Brickerhoff 2012, which showed that 74% of water bodies were failing to achieve a good ecological status by the 2015 deadline by the EU WFD. Both the headwaters of the Lapford Yeo and Little Dart didn't score as well as Sheepfold, but this wasn't surprising as both the Lapford Yeo and Little Dart, they come off of the downstream from the Tor, so the headwaters aren't going to be in as good of a condition as that of the Tor. In comparison though, Little Dart did fare better than Lapford Yeo, as it did have a moderate score. The diatoms were not as phosphorus tolerant, and there's more of a mixture. During both seasons, the ecological quality ratios were slightly different in the Tor, but they still followed that general pattern of being pristine in the Tor and then moving down, whereas Lapford Yeo was comparatively lower. Lapford Yeo also scored the lowest EQRs and the highest levels of phosphorus, showing that phosphorus is having an effect on the diatoms in the region. What was interesting was that in the first graph of Lapford Yeo, Menchen 1dy012, that was the poor ecological status, whereas when you went to the seasonal variation, it was Yeo Bridge, which had the poor ecological status. And then Little Dart was moderate, even though Little Dart had the best moderate scores and the lowest phosphorus levels in the region, the EQRs were still moderate, so that suggests that there may be other factors involved, such as flow, temperature, which may be having an effect on the diatoms in the area to cause such a low EQR score. And then, by continually using diatoms as bioindicators, it's possible to assess the situation further and then progress from there. Thank you for listening. These are all my references.